Okay, we're going to go ahead and get started. I want to welcome everybody to the first day, first semester of Circuit Analysis 1. My name is Brian Singleton, and I will be your professor for the next 15 weeks, possibly the next 30 weeks if you take part 2 of this course, Circuit Analysis 2. Now, a couple things before we get started I'd like you to do. Number one, make sure you watch the intro video that I sent out. I don't know if it was yesterday or a couple of days ago. I'm not going to take any time to go over the syllabus today. I do that in that video. In the video, the syllabus was from the course I taught in the summer, but everything is pretty much the same. The policy for quizzes and exams and all of that, everything's in there. I spent about 30 minutes detailing information about the course and the syllabus, so make sure you watch that. The second thing is, since we're using this web system, what you want to do is make sure that your microphone is muted. If you want to ask a question or make a comment, you can unmute your microphone, ask your question, and then mute your mic back. The way this collaboration system works, once you start talking, or if a dog comes behind you and starts barking, there's some other noise in your room, it cuts away from me and goes to whoever is talking at the time. So just to keep things together, make sure your microphone is muted. Anytime you want to ask a question, feel free to interrupt me and unmute your microphone, ask your question, and then mute your microphone back. You also have the capability to send a text message through the Collaborate system. However, my computer screen is over off to the side. If you see me look over this way, I'm looking at the computer screen. I can't read it from where I am. So if you have, some of you may not have the ability to talk, may not have a microphone that works, or you're calling in, you can send a text message and maybe another student will get my attention and read it. Every once in a while, I'll step away from the camera and I'll look over to see if anybody sent me something. So those two things. I do want to emphasize a few things that you'll need for the course, and I want to jump right into the lecture. You will need a 3-ring binder. You will need a 3-hole punch. The reason for that is the book for the course I'm not that excited about. I give a lot of supplements to the book. Of course, the things I post on Blackboard are those supplements, and I'll do that weekly. It's nice if you can print those out, put those in a 3-ring binder. Then you have a nice way, organized way to study the material on quizzes and exams. You'll need a ruler, some kind of straight edge, either a 6-inch ruler or a 12-inch ruler, preferably clear. It doesn't have to be clear, but what we use the ruler for, we use the ruler to make diagrams called schematics, electrical diagrams. And so you have to draw those diagrams or use the ruler to make straight edges. And sometimes if you have a solid color ruler or a wooden ruler, when you put the ruler over the diagram, you can't see what's under the ruler. So you can get away with not having a clear ruler, but I think if you have one that you can see through, it makes constructing the diagrams a little easier. The other thing you will need is a set of coloring pencils or pens. We use color coding to actually solve problems, and you'll see me do that as we get further into the course. And then finally, for lab, you will need a digital multimeter, a DMM. And I think I spent time talking about that in the video. If not, basically the meter that you'll need, we have meters here at the school. So if you don't have it, whenever we have our first lab, if you don't have it, there's meters here at the school. But sometimes a lab will call for 2 meters. You got to make 2 measurements. And if you only have the 1 meter, you have to disconnect that meter and reconnect it up in another way, another fashion. So it's just better if you have your own meter. The other reason you want to have your own meter is if push comes to shove and the worst happens, if this thing goes up, the number goes up because of COVID and they shut the school down, you can't meet. A lot of the labs you can do at home if you have your own meter. With the trainer, the digital analog trainer, and the meter, you can do much of this stuff at home if we have to, if we get to that point. So to do lab 1, which I believe I have posted on Blackboard, you will need that meter. Basically, lab 1, you're going to watch a video with the meter that you bought right there. Watch the video at the same time you have the meter. You kind of want to work through. In the video, the guy's going to talk about 3 quantities that we'll deal with this semester. We'll deal with something called voltage, current, and resistance. So in that video, he talks about what is voltage, what is current, what is resistance, and how do I use the multimeter to measure those quantities. So it helps if you have your meter right there while you're going through that. And the way you'll get a grade for that lab is you'll write a summary, you'll take a picture of your meter, include it in your summary, you'll send that to me or you'll hand it in to me. I'll have more to say about that later. So make sure you check Blackboard on a weekly basis. Typically on Sundays, I'll update Blackboard. I'll put out the next week assignments and homeworks and update everything. Now there was a mistake. I don't know why the link didn't go out for Blackboard earlier. I apologize for that. Normally, at least the day before class, you should have received a link from me to connect to the next day's class. So I don't know why that didn't happen. It didn't get sent some kind of way. So I don't know what I did wrong, but that was on me. So I apologize for that. It won't happen again. So I want to start class. Make sure that you text this number. You want to save this number in your device because the way I take attendance is I'll have you text EET 131. That's the class you're in. Your first name is in the text and your last name is in the text. It's critically important that you do that, especially for the first 2 weeks of class, because that's the way that the college determines if you attended the class or not. If you did not attend the class, or if you don't text me and I turn into financial aid that you did not attend the class, it can mess up your financial aid. So it's important that you do this. Even if I come in and forget to tell you to do it, save this number in your device and go ahead and send me that text right away. And then what I'll do is I'll use that to keep a log of the attendance. So does anybody have any questions for me before we get started? Okay, well, if you don't have any general questions, if you do, there'll be time at the end. You can ask me and I'll be happy to answer. The way I teach the course is I go through each chapter and I make an outline called the topic sheet. And if you had a chance to look at Blackboard, in the week 1 folder, there is a copy of the topic sheet and some other documents that you need to look at. But the topic sheet is kind of what I use to kind of guide my lecture. And at the bottom of every topic sheet, you will find practice problems. I like to lecture, pause for a minute, and then work problems. So what you want to do is make sure you have that sheet handy. So what I asked you to do was, if you have the ability to print, make sure you print out a copy of the topic sheet and have that handy. If you can't print it out, you can open it up on your device. If you can't do either one of those, I will put the problems on the board today and probably next time, but you want to make sure that you can print this stuff out. If you don't have a printer at home, when you come up to campus, if you need for me to print something, let me know during the lab session, and while you guys are doing lab, I'll be happy to print out anything you want me to print. No problem doing that. So with that said, I don't know if I'm skipping anything. I think the video probably should have been pretty clear, but you know there's a weekly quiz. There'll be one for this week. Nothing to worry about. It'll be something that everybody will do well on. But typically, the quizzes are based on the topic sheet. In the video, I mentioned that I dropped the 2 lowest quizzes. Because of COVID, I decided to drop the 3 lowest quizzes. I don't give makeup quizzes. I don't do that. So since I don't give makeup quizzes, then what I do instead of that is I'll drop the 3 lowest quizzes. So you can totally miss 3 quizzes. It won't affect your grade at all. Okay, so now exams, a different story. There'll be 4 exams this semester. One of those exams will be a take-home exam, and the other exams you'll take when you come in for lab. And you'll know a week or 2 before the exam when that exam is scheduled. So there's no way to make up an exam. If you miss an exam because you're sick or there's some kind of, like a funeral or something, you just got to have documentation that that's what you were doing, and then I'll make sure you get a makeup exam. But other than that, no late work is accepted. Well, homework I can be a little bit lenient with. Sometimes you don't understand something, you need more time. I don't mind that, but pretty much we got to try to stay on target with our exams and our quizzes. So having said all of that, make sure you have your topic sheet out, or you at least have access to it. And like I said, if you don't, I'll read off of this and I'll put the problems on the board, and then we'll proceed in that way. So let me get started. The first thing I want to talk about is this idea of a physical quantity. Now, in this class, we deal with three specific quantities. We deal with something called voltage, we deal with something called current, we deal with something called resistance. Those are the basic quantities. And then from those, we can talk about something called power and energy. We'll get to that later on in the semester. But those three base quantities, voltage, current, and resistance, those are the ones specific to this course. But right now, I'm just talking about any physical quantity in general. Any quantity, to express a quantity, it takes two pieces of information. To express a physical quantity, you got to have a number or magnitude and you got to have a unit. So no physical quantity makes sense unless it's expressed with both pieces of information. You got to have a number and you got to have a unit. For example, I might have a quantity of force. I can't just say 10. 10 what? Do you mean 10 pounds? 10 ounces? 10 tons? 10 what? So to express any physical quantity, you got to have a magnitude or size or number, and then you got to have a unit. So I want to spend the first part of today talking about number and talking about units if we get to this today. I don't know if we'll get to the unit part today, but if not, we'll pick it up on Friday. So let's talk about ways to express numbers and ways to express units. I'll do that in just a minute. I skipped over one thing though. The very first thing on the topic sheet, I want to stress, if you have the topic sheet, if you read Roman numeral 1, it talks about mathematics. It says mathematics is the language of science and engineering. Now, I want to take a second to think about that. Mathematics is the language of science and engineering. Now, you might wonder, okay, well, why is that there? In this class, we use scientific principles and we talk about engineering concepts. And so the way we express those as scientists and engineers is using the language of math. I want to go back to just kind of language in general. What is language? Well, you might think to yourself, language is a way we communicate. I have an idea in my head. I want to get it across to another person, to you. Right now, I'm speaking to you. I'm using the English language to transfer ideas from my mind or my brain to yours. Well, is that the only way we can communicate? Verbally, is that the only way we communicate? Of course not. There's written language. I can write stuff down. There's sign language. I can sign. There's many ways to communicate. Matter of fact, there's many forms of communication. Most of you right now, if your mother or your father, your significant other, they can come into the room. They don't have to say anything. If they're upset, you can just look at them and tell they're upset. If they're really happy, you can just look at them and tell, hey, they seem to be pretty happy. There's body language. We can communicate that way. We can communicate through poetry. We can communicate through music. There are many, many forms of communication. Mathematics is just another form of communication. Now, why am I spending time talking about this? Well, in this class, I want you to think of math that way. Too often, students write an equation down, and they look at an equation as a means to get an answer. I don't want you to do that in this class. There was a famous philosopher, Rene Descartes. Descartes said, I think, therefore I am. He's the one you probably heard that before. I think, therefore I am. He also said that mathematics is the language God gave us to allow us to communicate with nature. Mathematics is the language God gave us to allow us as humans to communicate with nature. In other words, Descartes was saying we live in a mathematical universe. If I want to understand nature, the way nature reveals herself is through the language of mathematics. So I'm saying all that to say this. When I put an equation on the board, it's not just an equation. That equation is trying to speak to you. Ask yourself, what is this equation trying to say to me? As a matter of fact, more often than the answer, what's really important in the equations in this class is the relationship between these variables, these quantities. And so I have more to say about that as we go through the semester. So back to this. A physical quantity. Any quantity I want to express, I got to have two pieces of information. I got to have a number or size or magnitude, and I got to have a unit. And I want to spend time talking about the way we represent numbers in engineering and science, and then we'll talk about some units that we use in engineering and science. We'll deal with both of those. So it turns out that in science and engineering, we deal with really big quantities and really small quantities. And I mean that in other areas like business or the social sciences, they deal with large and small numbers too, but nothing compared to what we as scientists and engineers deal with. We deal with the almost infinitely big or the infinitesimally small. We deal with numbers over a wide range. I want to give you some examples of that. One example would be the distance between the Earth and the Sun. If you don't know, the distance between the Earth and the Sun is 93 million miles. So just think about that. The Sun, think of the Sun is really a star. The closest star to us is the Sun, and it's 93 million miles away. Now, light travels at 186,000, not miles per hour. Light travels at 186,000 miles per second, but yet, even light traveling that fast, that distance of 93 million miles is so vast, so far, it takes light traveling at 186,000 miles per second. It still takes light 8 minutes to get to your eye. If you could some kind of way look up in the sun, which I don't recommend doing, but if you look at the sun, since it takes light 8 minutes to reach your eye, you're really looking at the sun as it looked 8 minutes ago. You can never see the sun in real time. It's a delay of 8 minutes. Now, the next closest star is actually 4 light years away from us. What's a light year? Well, a light year is the distance or the amount of time it will take light to reach your eye if it traveled at 186,000 miles per second, not per hour, per second in 1 year. Think of a photon of light traveling through space 186,000 miles per second. How far will it have gone in 1 year? That unit is vast. That magnitude is huge. The next closest star to us is 4 light years away. That's a number that you can't even imagine. And so when you look at that star that's 4 light years away, you're not seeing it as it is in real time. You're seeing that star as it looked 4 years ago. You're actually looking back into the past 4 years. We have stars, we have galaxies, we have planets, we have celestial bodies that are hundreds of light years away. And yet scientists can do calculations to study those stars and galaxies. The numbers they deal with are just mind-blowingly big. You can go the other way. You can think about tiny things. Like for a long time, scientists thought that the smallest piece of a substance you can have is an atom, and it really is. That's the smallest piece of stuff that you can have. But atoms are basically infinitely small. They're really tiny. But later on, we learned that the atom itself is actually composed of even smaller particles. They call these the subatomic particles. And those are the ones that you're familiar with, the electron, the proton, the neutron. These are really, really tiny particles. And to measure the radius of the nucleus of an atom would take a decimal point and a whole bunch of zeros before you get to any number that really makes any sense. My point is this: in science and engineering, we deal with extremely large numbers and we deal with extremely small numbers. So we got to have a convenient way to represent the number part of a quantity. There's 2 ways we do it. The main way we do it is we use something called scientific notation. In engineering, we use a subset of scientific notation called engineering notation. So what I want to do today, I want to spend some time talking about numbers and how to represent these numbers in scientific notation. And if we have time, we'll talk about engineering notation. And what we don't do today, we'll do on Friday. And then we'll finish up talking about units, systems of units. And then we'll talk about some other things that have to do with measured numbers. So what I want to do is talk about scientific notation. Now, let me pause for a second and say this. In this class, I got people doing calculus, and I got some people that you might be in basic algebra or something like. I got a whole array of people. A lot of what I'm going to say today, many of you, maybe even most of you, have seen before. If you've done this before, it's okay. Just consider it a review, because there's somebody in here that you may not have seen this before. And I'm going to assume that you don't know anything, and we'll all come up together. So if you've done scientific notation before, please still work along with us, just kind of as a review. And I promise you, we'll get to something that you don't know already. So let's talk about scientific notation. First of all, why do we use it? We use scientific notation because the numbers in engineering and science that we deal with are so vast, so big, or so small that we got to have a convenient way to write it. So scientific notation allows us to write a number in this form. If it's written in scientific notation, what we have is we got a number, we got a decimal point, and then we may or may not have another number. And then we have the multiplication sign, and then we have this 10 raised to a power. That's called an exponent of power. And the rule is, when we use scientific notation, is that the number over here on the left of the decimal, well, that number can't be a 0. We can't start it with a 0. That number has to be a digit 1 through 9. It can't be a 0. So this will be a 1 through 9. And you may or may not have a number here. And then the power, this is the power or exponent. We'll just call it the power. That power, what that tells us is the number of places we move the decimal. Depending on the number we start with, we're either going to move the decimal from the right or from the left. And we're going to count the number of times we move the decimal to put the number in this form. And once we get it in this form, however times we move the decimal, that's what we'll put here for the exponent. And at that point, we're almost finished. The only thing we got to do after that is determine if that exponent is positive or negative. How do you know if it's positive or negative? Well, if the original number we start with is bigger than 1, that exponent will be positive. If the original number we start with is between 0 and 1, then this exponent will be negative. So it's saying a lot, but it's much easier to see if you just see an example. Let's do the number that we talked about earlier, the distance between the sun and the earth, 93 million. Let's work with that number, 93 million. So if I take 93 million, by the way, let me pause here for a second and say this. In the United States, when we write a big number, it's common to put these commas in here like that. And I'll do that in here. I'll put commas in there. And it just kind of makes the number look a little better. You group the zeros together. It makes it a little easier to see. The problem is, in some cultures, the comma is like a decimal in our culture. And what I'm saying is, let's say I want to write the decimal number 1.25. In some cultures, instead of using a decimal point, they use a comma to represent a decimal point. They might write 1.25. So what scientists do is, often what they'll do is they'll leave these commas out, and they'll just group the zeros together. They'll leave spaces where the comma would go. And I've actually seen that some of my African students, they'll have a comma that they use for a decimal point. So if you ever see me do this, where I put these spaces here, that's the reason. My background is really in science. I have a physics degree and an electronics degree. So the physics part of me takes over, and I'll write numbers this way sometimes. So just know what I'm doing. But let's take 93 million, and I want to put that in scientific notation. So how would I start that? Well, the first thing you'll do is locate the decimal point, and of course, on this number, it's over here. And then what I got to do is I got to make this number, I got to put it in this form, which means I'm going to move the decimal over, and I want to stop when I have one place to the left of the decimal that's not a 0. It's got to be the digits 1 through 9. One of the digits 1 through 9. So I'm going to move. When I move that decimal point, I'm going to count the number of times I move the decimal point to get it into this form. And whatever that count is what I'm going to write here for the power. So let's do that. I'm going to start, I'm going to move the decimal over 1, 2, 3, 4, 5, 6, 7 puts me right there, and that's where I want to be. So to write this number in this form, I'm going to write this. I'm going to write 9.3 times 10 to the, and I had to move it 7 places. So I'm going to write a 7 there, because then the exponent tells me how many times I had to move the decimal to put it into this form. So I'm almost done. The only other thing I got to do is that 7 positive or is that 7 negative? How do you figure that out? Well, if the original number that we started with, the decimal number we started with, if that number is bigger than 1, then that exponent is going to be positive. If that number is between 0 and 1, then that exponent will be negative. 93 million is bigger than 1, and so I'm going to leave this as a positive number. 9.3 times 10 to the 7th power would be this number written in scientific notation. Let's do one more example where we have a decimal out front. So let's say instead of this number, I got this number, 0.00000123. Let's say I got that number. And I want to put that number in scientific notation. So just like before, now the decimal is already here, so I don't have to put it in there. I just got to move it over. So I have one place to the left of the decimal. That's the symbols or digits 1 through 9. So I'm going to move it and count the number of times I move that decimal. I'm going to move it over 1, 2, 3, 4, 5, 6. I move it over 6 times. That means my number is going to be 1.23 times 10 to the, I have to move that decimal over 6 places, 6 times. So I'm almost done. I just got to figure out if that exponent, that power, is it positive or is it negative? Well, if the original number I start with is bigger than 1, and I write that exponent as a positive exponent. If the original number I start with is between 0 and 1, then I'm going to write that exponent as a negative number. 0.0000123, of course that number is between 0 and 1. That means I got to write my exponent as a negative exponent. So if this is your first time seeing this, it's pretty easy. Once you do one or two of these, it's a piece of cake. This shouldn't cause you any problems at all. If you're already done this, then as I said, just consider it a review. What I want to do is practice doing some of this just to make sure everybody has it. On not quiz 1 will be easy. That's an easy quiz. On quiz 2, next when I give you quiz 2, I'm going to ask you to do some of this. You'll have to put some numbers in the scientific notation. You have to take numbers from scientific notation and write them back as a decimal number. You have to, in other words, reverse this process. And I ask you to do that on the practice problems today too. If you can put numbers in the scientific notation, it's easy to take them out of scientific notation. So here's what I want you to do. Take out a blank sheet of paper and get a pencil or pen. And if you have the topic sheet, at the bottom of the topic sheet, you'll see a section that says practice problems. And there's 3 practice problems on the bottom of the page. I want you to do problem number 1 and problem number 2. Practice problem number 1 and number 2. Now, if for some reason you don't have the sheet or you can't bring it up on your device, I'll write these on the board. I just want you working on them. And guys, let me say this. I don't even know how to start this. I think that working through the web, I'm glad we have this technology. I really am, because, pre-web, before the web, if we had this virus thing come up, there would be no way for us to have a lecture, to do school. The problem with this is I can't see what you're doing. Right now, I see only one person. The camera is on John. I see John's picture. All I see for the rest of you guys are I don't know if you're really there listening to me or not. I suspect, not with you guys, but I know last semester, the class started in the morning. I think people would log on and then go back to bed. What I'm getting at is you want to make sure you don't just sit there and listen to me. You want to work along with us. The way you learn this stuff is by getting stuck and finding yourself out of that stuckness, if that's a word. If everything I do comes easy to you, you're not learning anything. You're only learning when you reach some difficulty and then you overcome that. And to do that, you got to be here. So I'm asking you to please make sure you sign on and don't just sit there and listen and look at me. I want you to be an active learner. Get a pencil, paper, calculator, and as we go through these problems, then I want you to work them with us. That way, if you hit a wall, you can ask questions and we can help each other out. As we go through the course, the problems will become increasingly difficult, more difficult. Or I should probably use the word interesting, but you got to be here. So what I want you to do, take out your topic sheet or take a piece of paper and problem number 1 and 2, go ahead and work those out. The first set, you're going to put numbers in scientific notation. The second set, we'll take them out of scientific notation. In case you don't have your topic sheet, I will put the problems on the board. You go ahead and work them, and I'll give you a few minutes to work the problems, and then we'll talk about it. All right, so there is a list of problems. You're going to put these in scientific notation, and these are actually there's numbers A through F, so I'll put these up here. All right, so there you go. Give you a few minutes to work these, and then we'll talk about them and see how you do on them. So go ahead and do these, and we'll look at them in just a second. Get for the first one, anybody? Tell me what to write. What do we got?
5.6 to the fourth power.
All right, that's correct. So we started out with the decimal point right here. We had to move it over 4 places to get to 4. And since this is bigger than 1, it would be correct. Okay, good job. What about letter B? What'd you get for that one?
1.2 times 10 to the 6th power.
Continue on looking at the inauguration,
Okay. So we started here. Let's move it over 1, 2, 3, 4, 5, 6. Exponent is a 6. The number is bigger than 1, so we roll it as positive. Now this one, be careful. This number is between 0 and 1. So when I move that, my exponent will be negative. Anybody get an answer for this one? What would that be?
5.0 to the negative times 10 to the negative second.
All right, perfect. That's correct. And then this one, the same way. I'm going to move it over and get what? 4.10 to the what?
-3.
All right, so these two numbers are between 0 and 1. So I wrote the exponents as negative. This one, I didn't have my glasses when I counted this. I think there's 10 zeros here, if I count it correctly. If I count it correctly, then this will be 5.6 times 10 to the, I got a negative 11. Is that right?
That's what I got.
All right. But this other one is kind of stupid. I don't even know why that was on there. This one, it's already in scientific notation. It's 1.3. So there's one place to the left of the decimal that's not a 0. So if you want to put it in the form of scientific notation, that would be a 0 because you don't have to move the decimal at all. But I would never ask you to do a problem like that on the quiz. So problems A through E, if you understand those and you can do them, without much thought, then when you get to that on the quiz, it should be pretty easy for you. Anybody have any questions on how to take a decimal number and put it into scientific notation? Any questions or comments? Okay, well, let's go the other way. They want you to take numbers from scientific notation and write those numbers as decimal numbers. And that's actually, if you can put numbers in the scientific notation, then everybody can reverse the process and take them out of scientific notation. I will, however, since those problems are listed, I'll put them up here and give you just a minute to do these. You should be able to do them pretty quick. And you might have already done them, but I don't know if everybody has a handout or not. So I'll put these up here and you just kind of do them real quick. I don't have my glasses, but I think that's 2.66 10 to the
7.
7. And 7 is so tiny. Then 3.75 times 10 to the
-8.
Thank you, -8. And 5 times 10 to the -2.
Yeah, -2.
And 1.7 times 10 to the
4. Fourth.
4. Okay. I need a longer arm to see this. All right. So, I mean, this is like just so easy. So all you're going to do, if the number is positive, you got a number that's bigger than 1, you got to move the decimal to the left. And if it's negative, it's between 0 and 1, so you got to move the decimal to the right. Or I said that, move the number to the right or move it to the left if I have a number between 0 and 1. The thing is, what I usually do is I got to move it 7 times for this one. 2 of the times are already taken up by these 2 6s. So I just got to add enough zeros to get it over 7 times. Well, 2 of them already are taken up by the 2 6s. So I just got to add 5 zeros. There's 2 and 5 is the 7 I need to move it over. So what I usually do is just write out the number. I gotta add 5 zeros to make a total of 7. So I'm gonna add 1, 2, 3, 4, 5. I put the decimal there, get rid of that. And then if you wanna put commas in there, just to make it a little easier to see, or spaces, you can do that. So I think everybody can pretty much do this. So I'm not gonna, well, we only got like 8 minutes. So we'll work these, and I'm not going to have time to go into engineering notation today, but I do want to do one more thing. We'll finish these up, and then I want to give you a table. It's called the table of metric prefixes, and this is going to be on quiz 2. One of the things on quiz 2 is I want to have you take numbers and put them in the scientific notation, just like we did here. I'm going to have you take some numbers out of scientific notation, like we're going to do here in a second. But the other thing is I'm going to give you this table of metric prefixes. Now, I have a sheet on Blackboard that says understand. Don't memorize, but understand. I'm big on understanding. I don't like people to memorize. You can't memorize your way through this course. But there are some things you just got to memorize to be able to do them. For example, when you learn your multiplication, you have to memorize multiplication facts before you can do multiplication. So certain things you got to memorize, and one of the things is this table of metric prefixes. So I'll stop there, and then we'll pick up with that on Friday, and that'll take us right into engineering notation, which is really what I want to get to. So let's go ahead and put the answers up for these. Here I want to move the decimal to the left. I need to move it 8 times. One of the times is taken up by that 3, so I'm going to add 7 zeros. 375. Now I put my decimal point out here. Now it's okay to leave the decimal point there, but usually what you want to do when you have a leading decimal, it's nice to put this 0 on the other side. I mean, there's no difference between that and this. It's the same number. But when you put that 0 on the other side, it just kind of makes that decimal stand out a little bit better, a little easier to see. So always put that leading 0. On this one, I got to move it again to the left 2 times. One of the times is taken up by that by the 5 right here, so I only got to add 1 0 to that. So 0, 5, 5, 1 decimal point, and just for emphasis, I'll put the other 0 over there on the left. And then this one I'm going to move to the right 4 times, but 2 of those times are taken up by the 6 and the 7, so I just got to add 2 zeros to that. Decimals over here, if you want to put the comma in there, and that's it. So I think taking numbers out of scientific notation, if you can put it into scientific notation, is really a non-problem. Everybody can do that. I don't think I've ever had a student with an issue with doing that if you can do scientific notation. Okay, so anybody have any questions on scientific notation or anything we've talked about so far in the class? Any questions or comments? Okay, well, I want to do one more question. Okay, I want to do one more thing. I got about 5 minutes. There's enough time for me to give you this table, not enough time for me to do engineering notation. Let me say one thing before I put the table on the board. All of these lectures, I don't know if I said this already or not, I record all lectures, so you will be able to go to, at some point, go to YouTube, and you can rewatch any lecture. So if you need to play this over again, that's the beauty of recording everything. The bad part is some students, when this becomes normal, the class, you'll say to yourself, I'll just watch the recording. But watching the recording is not like being here live, because you can't ask questions, obviously. So always come to class. But if you miss a class or you need to repeat something, I'll send links out maybe once or twice a week that'll link you to a YouTube channel that has all these recordings on it. So if you need to watch something over, you'll be able to do that. Now let me get this table. Take out a sheet of paper or your notes. Write this table down, and I want you to study this table. And we'll pick up with this table. We'll start with this table on Friday. This is called the table of metric prefixes. And we use this table of metric prefixes. Once we learn how to put numbers in the engineering notation, I can use the engineering notation in this table to write those electrical quantities, voltage, current, resistance, in a special way that I'll show you on Friday. So the table has 3 columns. The first column is the prefix. And there's a whole lot of these prefixes, but you're only responsible for the ones I'm going to show you. Mega, kilo, milli, micro, nano, and pico. Mega, kilo, milli, micro, nano, and pico. Those are the prefixes. So you want to know those prefixes. Associated with each prefix is a power of 10. So I call that the power. So mega is 10 to the 6. Kilo is 10 to the 3rd. So 10 to the 6, that's a 1 with this many zeros. A 1 with 1, 2, 3, 4, 5, 6 zeros. So mega means a million. Or kilo would be a 1 with 3 zeros. Kilo means 1,000. So I can go ahead and write all these powers. Milli is 10 to the minus 3rd. Now, remember in your math class, they said that if you have 10, or you have a to the negative exponent, a to the negative power, that's equal to 1 over a to the n. So if I have a negative power, I want to express that power as a positive number, I can just move it down here to the denominator, and now that exponent is positive. So if I wanted to, I could take that 10 to the minus 3rd, that's like the a to the minus n, and I can write that as 10 to the 3rd, that's like the a to the n, but we know 10 to the 3rd, we said that was 1,000. So I can see that a milli is 1 over 1,000. It's like taking a unit and dividing that up into 1,000 pieces. So a milli is a really, 1,000 for the TH after it. So you can do this thing with all of these to kind of understand what you're dealing with. But anyway, micro is 10 to the minus 6. Nano is 10 to the minus 9. And the last one, pico, is 10 to the minus 12. So in the table, you got to know, be able to recall prefix and tell me which power of 10 is associated with each prefix. And then the last thing, I got about 2 minutes, the last thing is the symbol. Associated with each power of 10 is a symbol. The symbol for mega is a capital M. The symbol for kilo is a lowercase k. For milli, it's a lowercase m. For micro, now micro, some people do this. They put a U for micro. That's actually not right. It's called, the symbol is like this. That's the Greek letter mu. Mu. It's like a U with a tail in the front and in the back. Now, if you use U for micro, I'm not going to mark it wrong, but just realize the correct way to do it is to put the tail in the front, because that's the Greek letter mu. So I'm going to use that mu like that. The symbol for nano is a lowercase n, and finally for pico is a lowercase p. Give me 30 more seconds. I got one more thing I want to say about this. I want to say something. I'll explain why on Friday, but it's important that you make your uppercase M's look like your uppercase letter look like uppercase letters, and your lowercase letters look like lowercase letters. So as an example, some students, when they write a capital M, they'll do it like this. Here's a capital M. Here's a lowercase m. Well, to me, that's just a big lowercase m, and that's a little lowercase m. If I want to make a capital M, I got to show it like this, with the points on it. So this is not, if I make a small, that's not a lowercase m. That's just a tiny uppercase m. If you mean uppercase, you got to show these points on it. If you mean lowercase, it's going to be smooth. And I'm not being silly or picky. on Friday, I'll explain this, and you'll see why this is important. So it's important that you make your uppercase letters look like uppercase letters, and your lowercase letters look like lowercase letters. M and N are the ones I have trouble with. Sometimes people make a capital N like this, and a lowercase n like that, and that's not a capital N. A capital N looks like that. A lowercase n is like that. So just be aware of that. And again, I'll say more about that on Friday. So guys, sorry, I think I went over a little bit. We'll pick up with this on Friday. Let me pause for a second and ask you, does anybody have any questions for me on anything we talked about so far, or any questions in general that I might need to address? Any questions or comments?
No, sir.
All right. Well, guys, it's been fun today. I enjoyed this. Looking forward to meeting everybody. I'll see you on Friday. Please stay safe, and we'll pick up with this next time. See you soon. Thank you.
A quick question, real quick.
Sure.
Sorry. The assembled analog digital trainer.
Yeah.
Is that something you would recommend buying off of Amazon, or is there a certain?
Here's what I can do. I think in the bookstore they're like, I think they're over $200 in the bookstore. I know students get them online for around $150. You'll save money if you just go to another website and get it. As far as Amazon, I would say whoever gives you the best price. If anything less than $200, consider it a good price. There is a website though that Dr. Whaley, the chair, he sends his students to get those. If you want me to, I can find the link and send it to you if you want. But you know, it just depends on the price. If you can get one for around $150, that's a good deal, or less.
Okay. I was just curious.
Okay.
Thank you.
Oh, I was going to ask you, is that Mike? What's your name, Mike?
Jason or John.
John. Well, no, it was not John, but Michael. Michael Willer. Are you listening to me, Mike?
Yeah.
I'm just looking at. I see a guitar behind you. Are you a musician?
Oh, I play a little bit here and there. Yeah.
Oh, are you not in the band?
What's that?
You're not in the band? I thought you might have been in the band.
No, my brother-in-law's in a band, so he's been hustling me to play.
Okay. What kind of music you play?
I just play, basic classic rock. He plays kind of more hardcore death metal type stuff.
Okay. All right.
Yeah.
Cool. All right. Thank you. And John, is that your? I can't see. That's your little daughter.
Yeah, that's my daughter.
Oh, what's her name?
Ava.
Hey, Ava, how you doing? How you doing, Ava?
Today's her 6th birthday.
I see she has a crown on, right?
Yeah. Well, if you guys need a drummer for that classic rock band, let me know. I play.
Oh, that's awesome.
It's been a while though, but I do play.
Okay. Well, guys, thank you very much. You guys have a great rest of the day, and I'll see you on Friday.
All right, have a good one.
You too, Mr.
Bye-bye.